Hi, I'm going to give you a demonstration about EnVision's crude distillation unit simulation. The application you're looking at is a PC-based simulation, and we have a number of crude units. For example, CDU Advanced, this is just atmospheric crude distillation unit. They come in different engineering units, PSIG, degrees Fahrenheit, bars, Celsius, some different languages, and we can also do Chinese, translation for the manuals. So we have one with atmospheric column. Other one variation is we have atmospheric and high vacuum fractionation combined. And then we have a third variation, here it is atmospheric and mild vacuum fractionation with the naphtha splitter in the overhead section. So let me choose bars as the unit and just go over the graphics. And I'm just running the simulator, which means it's doing calculation, pressure, temperature, flow. We have light crude, heavy crude. I can change percentage of these crude fractions. Then they are pumped. There's a backup pump, and then it goes through preheat train with kerosene pump around. Kerosene product is cooled. Light gas oil pump around. PAs pump around. And then atmospheric bottom exchanger. There's a bypass valve to control the desalter inlet temperature. And then water is added here. We're adding chemicals here. Then it goes to a desalter. And there's a desalter bypass, for startup purposes. In the desalter, we have a switch for turning the voltage on and off for a better separation. Water and crude oil is separated, and water comes down as foul, dirty water, and the crude oil leaves under pressure control. Then it splits into two passes, and then we have additional preheat train with LGO and HGO pump rounds and bottoms. Then it goes to a pre-flash drum. In pre-flash drum, the vapors go directly to the atmospheric column, while the liquid part is pumped to a high pressure and goes through more preheat train and gets heated to around 230 degrees Celsius. Then it goes to a crude furnace, and this is a balanced draft with an FD fan, ID fan. And crude comes in, splits into four passes, and goes to the radiation and convection section. And you have fuel gas and pilot gas and airflow. We have outlet temperature is controlled by controlling the fuel gas flow. And if I were to go to the next page, we have burners. So it has 12 burners. First three burners affect pass 1 and likewise other groups. And we can click on individual burners, adjust the airflow, air registers, fuel gas flow, pilot flow. We can, igniters, to turn the pilots on first time. And then when we have an overview for the main fractionator, atmospheric, so that's where the heater outlet is coming in. So we have, overhead system, naphtha or gasoline or wild naphtha is coming liquid. Gases go to off-gas compressor. First draw is kerosene, goes to a side stripper. And the next draw is light gas oil. And third gas is heavy gas oil. And bottom is residue that goes to either vacuum or some other location, some other process or tanks. So this is the overview. Now if you want to operate it, then we have detailed display for overhead system, like pump around is in a flow control, and these are the feed preheat exchangers. Overhead we have cooling water exchangers. We can click on overhead condenser to see how much heat is being transferred. We can foul overhead condenser. Followed by a trim water-cooled condenser. Water and hydrocarbons are separated, so you have reflux flow that controls the overhead temperature, and this is the reflux flow, which is in cascade. Set point changing is like clicking on a set point and be able to do that. Pumps can be started, can be stopped. We have so naphtha going to naphtha wherever it goes. Sour water is separated from the boot. Then we have middle section, additional pump around. Then we have kerosene side stripper and a light gas oil side stripper, and it's cooling. And then we have bottom section. We have the last HGO, and then we have the bottom feed bottom pumps, and they further cooled and then goes to residue to battery limit someplace. And then this is meant for recirculation for startup purposes. So if I were to look it up here and then say, okay, I just want to reduce the pass flow, only one pass flow. So first of all, alarms that you're hearing in, you can go to alarm summary here. You can see what type of alarms came, you can acknowledge them. We can look at group display, look at different controller outputs, set points, and PV value. You can change proportional, integral term. By the way, whatever I did, the HGO product was off spec, so it gave me a plant alert, and then if I were to click on explain, it gives you probable causes and suggestive actions. Now these can be done in different languages, Spanish, German, Chinese, so that's okay. We have historical trend, and this is where all the process variables have trended up to 16 hours. So we have zoom, pan features. We can look at the values anytime. If I click here, it gives me changes, all the changes I made and alarms that came in. So if when you do in different languages, this description will be in different language. Then if I say help, the whole operating manual is here, startup, shutdown. So again, we localize this to a specific language. Then we can change from here ambient temperature, cooling water supply temperature, or even crude composition, or fuel gas composition, just like a battery limit condition. We can put more water in the crude and see its impact, what happens. We have different types of malfunctions for troubleshooting, loss of cooling, exchangers fouling, there are leaks in the exchangers, control valve fails, transmitter drifts. So here you learn about troubleshooting, crude unit, and so the idea is first you go through tutorial, learn the fundamentals, then you learn about the controls, normal operations, and do startup, shutdown, so you understand the crude unit. And after that, you go through battery limits and malfunctions, so you understand the troubleshooting part. So, like they say, any new knowledge not utilized in the next 72 hours is lost unless it is practiced. So this is where you come and practice, and then gain an understanding at a high level, how the whole unit works. And the next stepping stone after this would be, some of the alarms have cleared up, so so I'm just taking them out. So the next stepping stone after this would be to go to full mission simulator or unit specific training, where they learn about your crude unit. So that was a brief overview about our atmospheric crude distillation column. Then we have other variation. In this case, this is atmospheric and high vacuum unit. So feed system looks similar, except some heat integration with vacuum unit is here. Desalter is similar. This is similar. Pre-flash again. Some more preheat. Here HVGO and vacuum bottoms are here. Furnace looks a little complicated. Similar to, it's a forced draft furnace, except we put some advanced controls here for temperature. Previously it was temperature to flow, and this time if I were to click on advanced control, so we have temperature, we have cross limit lead lag controls. So temperature will control not only the fuel after applying cross-limit controls, but also controls the airflow rate. And then we have analyzer to control excess O2. In the case of fuel gas flow, eventually we are doing it slightly different here. Here, the temperature controller, so we have cascades to advanced control. It goes to the fuel gas flow controller, but there is a low pressure fuel gas override, so that will ensure that it maintains certain minimum flow to maintain fuel gas pressure and prevents the compressor from tripping. Burners, we put only fewer burners here. This is similar to what we saw before. And overhead, there are some slight changes, design changes and how we do pump around. And this is the bottom section. Then what happens is in the bottom here, this is going to vacuum furnace. So again, you control the vacuum furnace. This is a natural draft furnace. It has only 8 burners. And then we have an overview page for the vacuum column. Then we have an overhead system with the vacuum system. Then midsection, we have pump around and HVGO draw and the vacuum bottoms. And this is for startup, recirculation, where it comes back so you can keep the vacuum system on should the atmospheric section fail. Something I did not go over the interlock. So the previous model, they also have it, but again we have a furnace strip on high draft, or fuel gas gets stripped, on low pass flow or high outlet temperature, low furnace fuel gas pressure. And similarly, there are some interlocks associated with FD fan, ID fan, and the vacuum furnace. So they all come reset, etc. explicitly very clear. So from a learning point of view, it becomes very, very easy to understand cause and effect. And we make our products like Apple's products easy to use, yet there is a complexity behind it. And our clients feel very, very comfortable as a learning tool. So that was the one with the high vacuum column. Then we developed another one. This one is mild vacuum column. So here we basically provide an overview. So you have preheat train, atmospheric section, overhead recontacting. We have a debutanizer and naphtha splitter. And then it has only 2 side draws, kerosene and LGO. Rest of it goes to vacuum. And vacuum is mid-vacuum or mild vacuum, not high vacuum. So it's primarily targeted for diesel production. And this is sometimes very common in Europe. So if I were to look into the feed section, this sort of looks similar. Preheat train is slightly different. Then we have desalter. Some more preheat, pre-flash column, more preheat. Crude furnace, okay, so this is similar again, but this is a forced draft furnace. So here we decided to do something different, so it's a forced draft furnace. And then we have 4 burners. Overhead section, so the difference here is we have kerosene and LGO. Pump around is a little bit more complex than previous one. And then we have a detail page for the overhead section, and recontact section for the overhead, which is the liquid and the gas. They are recontacted here after compression. Then you have additional separation gases, fuel gas, and this is while naphtha will go to a debutanizer, and then from debutanizer, the overhead butane will go to the gas plant, and the bottom product here, which is actually goes to a naphtha splitter, so it splits into light naphtha, heavy naphtha. So this can be gasoline component, and this will go to typically a reformer. Okay, so that's the overhead section. Then we have atmospheric detail sections here, and bottom section. Then we have vacuum furnace and overview section, slightly different here. Here draw goes to a side tank, and then from here we are moving it. And then we have some more detail pages and overhead section, bottom section, and then again trips and interlocks. So this is more a European design in a mild vacuum. So in general, you can definitely choose, you can choose one of these two designs. Depends on which one is closer. Or if you want to train just on atmospheric, you can just use atmospheric. And I want to take another minute. This is a Spanish version, so you can see the text here is in Spanish. Help guide is in Spanish. And so likewise, we'll localize it, and we should be able to do this in different languages. Everything is in English, but key text, malfunctions, and battery limits, etc., they are in a local language. This way, people who use it, they need not know English. So thank you very much for your time. If you have any further questions, please contact your GSE representative, and we'll be happy to answer more questions. Thank you.